Welcome to our third tutorial where we are going to look into Unity UI. For this matter, I added some sprites I have and some background for some button if needed. And what we're going to do, I also changed our cube to be a character with a nose. So it has a red nose. So basically we know where he's looking at and how to move it forward. Just a small visual thing to make it a lot easier. How did I do that? Basically, I created a new cube, placed it there, and I created the new material called red, which is the same as a white except a red color. Very simple, and that's it. What do we need for our UI is we need to create, so if you right click here, you get UI, and the first thing you need is a canvas. So this is where we are going to paint our UI on. Just like a painter, this is quite similar. Next thing we need is, so you have text, image, and raw image. What is the difference? Well, we can create the difference between image and raw image. So raw image requires a texture, while an image requires a sprite. These are basically set in the import settings of the sprite you're taking. So when you're working with UI, it's always best to use sprites, 2D and UIs, not textures should be used for models. There are some exceptions when you want like a very big background, you can have them as textures, but what also work quite well is just have them as UI sprite. See, still the big changes are on sprite mode. So here you have repeating, so basically repeat will make it a tileable texture, how the filtering goes, where is your alpha coming. If you put on a sprite, you have a lot more options. So there are multiple sprites, so you can say, okay, or there's a single sprite actually in here, the pivot is in the center, or I can customize it. It's a polygon, so you have a lot more options on your sprite itself and not assume it's a square one. That is why we will be using always images and not raw textures for this. So we're going with sprites. First thing, like let's say you want a background on your UI, you can easily do that and by stretching your image. So you can say that your image will always be the full screen and it will work accordingly. So this is very important to know. You can put it where you can put the pivot at some specific place. This will put the anchor here, and that means that these coordinates will always be part of this. You need to know that the coordinates are actually working from the pivot, and this one you need to change manually. So you see now my pivot is here, my anchor is here. So if I attach something underneath it, it will be based on this corner and not the middle of the screen. But we are not looking into this. What do we want is, well, we want a very simple image, and I would like it to be a backpack. So I would like it to actually be at the bottom here. This will be my inventory, so I'm changing the pivot point to be at the bottom right, and I'm gonna change the pivot to be there also. After that, I can say I want it to be 10 away from the border, 10 up from the border, and all of a sudden I have a button locked into these coordinates. If I go here, I move around, you see it is locked into that position. It will always be 10 pixels away from the border and 10 pixels away from the bottom. This is a very good way to have your UI adapt to different resolutions. You can also have something similar. Let's say that underneath this, we're gonna have a text, and if I would write it correctly, inventory. As you can see, it's in the middle. Uh, you have quite a lot of possibilities here. So on the text, you actually have what it says. You can change the font that is being used, so you can drag your own fonts and use your own fonts in here. You have the style, is it bold, and italic. You have the size that it basically has. How big is the line spacing? Is it rich text or not? How is the line? So you can be, I want it to be centered. I want it to be on the middle here. You can align by geometry or not. You can say like, okay, if there is too much text horizontally, you can just continue. So it just runs out. If you say wrap, it will actually make it fit in there. Same with vertical, you can just say, okay, if vertically I have too much, what it will do is it will actually stop writing. So it's still there, but it doesn't display it. But you can also have overflow, and then it will just keep going down. So this was inventory. And the next thing is best fit. It will actually try to fit as good as possible in here. So position, we actually want it to be fitting in here, and I would like to have my inventory written at the top. What does this mean? Well, I need to lower my height, but as you can see, it actually keeps it in the middle. If I change my anchor, position of this one, put it there, and all of a sudden it's written up here. You can also drag here, and you see this works. And now I have my inventory written here. And because I put back the truncate, it will actually make it smaller. If I go look at the game, it says inventory with the bag in there. So now we know how to make text, we know how to make images. When we create them empty, we can also change them. And what we're actually going to do is create empty inventory button. And then we're going to add a button on this. We're going to put here, this is the label, and this is the image. So here, target graphic. So this is basically our image. So when we're going to click on our image, it's actually going to have an interaction. At the moment, as you can see, the color change when you press on it, it gets darker. For example, if I put this to red, I will have a red overlay when I'm pressing it. Nothing here. Also, you can see like how the navigation goes. This we will not look into. there are two ways to add now some interaction on this. So you can add here, where you select a scene, or you can select an asset. For example, where are you? So we could actually send something to our cube, and we don't have a functionality that allows on click. The other option is to actually write it into a script itself. So what we're going to do is we're gonna create a script and open inventory. So this script will be added to our button. Now, if I switch here, I'm going to drag it into the correct screen. So this is the default way how it works. You already noticed that. We have our button, and if we right click on it, resolve using Unity Engine.ui. So now we have our button. Now, what you can do is you have the on click, and then you can add a listener. And what does it do is basically what we're now doing is we're gonna have an action. What is the method going to be called once we get there? So I'm gonna make private void I'm gonna say it like, okay, let me know when I click, I want to execute on button clicked. And very important at the same time is when you add listeners, you need to remove them. So there is a functionality called onDestroy for objects that are mono behavior, and you can have and now we're basically removing. So here you can see what it is. So this is a callback function. So debug.log is something that will output into the console information. So now we have our open inventory there, and it requires a button for it to work, of course. So we will drag our button in here. If we press play, it doesn't take it. I'm gonna attach as usual. Oh, I didn't have the logs enabled. That's why. So it's still running. That's why it's not visible. If I would enable it, there we go. Button has been clicked, and you see the number actually going up. So we can now click on our button. What is the next thing that we can do is actually create a panel, for example, where our button will be displayed in. So the first step is done. So you now have seen Now here, if you want, so we're going to disable this. We can add here in assets, open inventory. So this is when it's going to be run, and this should have the same result. As you can see, this does exactly the same. When a button is clicked, he will call this script and this method. And it's important to know that you can so open inventory. So you can add it there twice, for example. And if I clear and I press, it is clicked only once in this case. Here you can add it multiple times and it will be executed multiple times as well. If I have both scripts running, it doesn't take it. But so that's also important to know. We can click on buttons, we can actually do something in our buttons. So this is the first step of your UI. And the next thing we want to do maybe is open a panel and display our inventory. For this, we're actually going to create a panel. And it's of course not when running. When you have the game running, you can't create anything. It will just remove it. So now, for example, this is my panel. I want it to be stretched over the full screen. This is my inventory panel. First thing I will create then is an image, which is going to be also stretched on the full screen, but it's going to be black with 100 alpha. Okay, what is the reason for this is the idea is that once we're going to display the panel, we are going to use the black background as a way to close the panel. So you will have an X button if you want. For PC gaming, that's how it works, but for mobile gaming, basically tapping outside of the panel is enough. So at the same time, we're going to add a button here which uses the image that's on it, and we'll create a script to say like close panel, which will basically close the panel. So we have our background, so now we have, so let's call it background, and this is foreground. In our foreground, we want an image, and we will use from here the window test. And we're in run mode again, of course. Not too much work, but there we go. Create empty foreground, add component image, and you want our window test there. Next thing we're going to do is size is a bit small, so we're going to make it, for example, 500 by 500. This will be always in the middle of the screen. This is also important to know is how the UI system works in Unity. It basically is going to run through all of this and display the last window on top of. So if I would move my background under my foreground will be displayed behind the background. This is very important to know to not have the weird effects of, for example, I want to have an image here with my portion, but if I put it under here, it doesn't display. So it always needs to be here, or if it's part of the object, it will always be on top. So it will display this first, and then all the children, the next one, all its children, and so on and so on and so on. Now we have our inventory. Let's see, let's make it a bit bigger because we got space. 800 by 600. And you see this is where this is constant pixel size. So here we actually have our canvas. And we can say that we want actually the screen to actually scale with our screen size. All of a sudden our screen is 800 by 600. Our inventory has been kicked out. And our foreground is now everywhere. So why is this? Our inventory button is written here, but our image is nowhere near our button. So we change it. We're going to place it back. And here we're going to put this at the bottom. -10. Of course, we need to change this. -10, 10. It's back at the bottom. So also important to know is you can move these outside of. This is why usually I have the main object placed where it should be, and these actually have position 0, 0, 0, 0. And it's a lot easier to maintain that way. Now we change our canvas size, and this is now quite important. So we're gonna go 600 by 500. If we play the game, again, this will scale accordingly because everything is set to stretch on the main, and these just follow. This has width and height, but it will always be placed in the middle. We can lower this like that. So as you can see, it stays to the middle. This one stays in the corner. I've already been doing half an hour, and I have not even the panel ready. We're gonna move a bit forward. Text on this. We have our title, and now what you want is actually to display an inventory. For this there are a few things you can use. There is a grid layout group. So, this, if we create an image underneath it, we give it a hammer, you will see that all of a sudden we do not have access to its position and its size. So this is all overwritten by our grid itself. So we want, for example, the grid to let's we can go 6 and 580. This is perfect. We want it to be from the top. Yes. Pivot as well. To come from here, and then we're basically going to. My OCD always wants to have nice numbers here. Let's see. 500 brings us too far down. We take 4, not enough. 450, it looks okay. So now, what we're going to do is we're going to add a couple of items here just for display purposes. So it will automatically place them. So you can say, where do you start? Oh, for some reason, don't want to change. Ah, there. So how it's aligned. Are you going horizontally or vertically? You can have a fixed count, but you can also have, for example, spacing between them. So I say I want 5 pixels in between in height and you will have a nice grid setup like this. At the other hand, you can say like, yeah, I want you to keep 10 pixels away from the left, 10 from the right. This doesn't change anything because there's lots of space. I want maybe 15 from the top and 30 from the bottom. And if we start duplicating enough of these, you'll see it tries to accommodate what you want, but it will overflow. So that's also important to know with the grid, is you can set fixed column count and things like that, but basically what you will have is it's always limited in, it doesn't stop going forward. So now we're going to delete a couple of them, but this is a very nice system, for example, to set up. For example, if you say I want you to be top right corner, 1, don't want it to change, but what I actually wanted was for it to be a lot smaller. Then all of a sudden I have a lot of free space here. I say no more borders to left and right, not to the top, not to the bottom. We have spacing, so I need to keep that in mind. 1, 2, 6. So maybe if I go at 375, it will look 80 there. I can go 330, and then we have 6. So this is a nice way to make an inventory. If I change cell size to 45 all of a sudden, I can fit in a lot more. I get space to do something else here. What I can also do is have like buttons here for different slots of inventory, or I can have a scroll list that we will look at some other time. But now this is how we can create an inventory. Now we're going to have 2 ways of actually displaying it. And the first thing we're going to do is actually drag our inventory panel outside of it, and we are going to hide it. So in our open inventory, I'm going to take this one back. We want to display the panel. So public game object inventory panel. So this is the wrong way how to do it, but I'm going to show it first because this is the easiest way of doing it as well for new people. So I just give him the panel and then I tell him, so give me a lock, and then if I have a panel, set it active. This is also important to have checks. For example, I might not have a button here, so it would actually give me an error. So we have to check that it exists. Also, same here. Make sure it exists before you try to interact with any component. Okay, so now I have my panel there, I have my button there, I press play, and it shows my inventory panel. So what are we actually going to do is, we don't want to show it from here. What we want to do is actually load it a lot more easily than that. So what I'm actually going to do is I'm going to create a new script, which is the UI manager. And my button is not going to open this. It's not going to have a link to it. It's going to be a very generic button. So panel path. So the first thing I need to do is open my UI manager, and this is very important to know. This is the first time I'm going to mention it, but our UI manager is not going to be mono behavior. So we are now creating a difference between our logic and our visual parts. So this is our visual part, and this is where a lot of possibilities are up for us. So we have public static void open panel. And it will receive a path. So what does this do is, this is OOP, so object-oriented programming, and static means you don't need an instance of the class to actually run it. So everything in our UI manager will be static. The result is here, UI manager dot open panel, and then our panel path. So we're actually going to load our resources and display them as we need them. So if we go to our button, we have our resources, and here we have inventory panel. So on our inventory button, our panel path will just be inventory panel. Later, you can have, for example, create folder, UI, create folder, panels, and we can put it in here. How will that influence? Here, easy, it becomes UI slash panels slash inventory panel. So now that we have our path, what we need to do is we actually need to find it. So we're going to try to load our specific resource, and we want it to be a game object. Then we need to check if we actually got something. Or if I'm going to delete everything, it's not going to work. So if we have a resource, that means that we actually found our panel prefab here. But that still doesn't display it onto the project. So the next thing we need to do is we actually need to instantiate it. So and here is a little trick. I'm going to show it in the inventory. So this is MonoBehavior class. Here you have instantiate, where you can create a copy of an object. Because UI Manager is not MonoBehavior, it doesn't show up, but it is a static method, so you can actually call it from anywhere. So we're actually gonna instantiate our resource. What does it do? It's actually creating us a copy of our resource that we have available to use. So now we actually have our panel created. And if I go here, you will notice that if I press play, I click here, we have panels being created. They are not visible because I saved them as not visible, but if I go like this, they're still not visible. The reason is these are all UI elements which are not located under the canvas. So if they're not located under the canvas, they basically will never display in here. So what do we need to do? And you see it also scales it down at that time. So we have two things that we need to fix at this moment. First of all, we don't want it to keep opening new ones. Like once we got one, it's enough. And the second thing, we want it to actually be part of our canvas. How are we going to do that? Well, we're going to keep it quite simple. We are, first of all, if we go to our UI Manager again, what we are going to do is we're actually going to save our panel. Again, different ways of doing it. You could have asking opening method to open for each panel, and then you can keep it there. Here we want to keep it as generic as possible for usability. So we are going to use generic specifics for this. So we're going to call it private because it doesn't need to be distributed, it's going to be static as well. As we said, nothing in here is going to have an instance. And it's a new dictionary. So now we have a dictionary with our data. The question is, why are we making a dictionary? We could make a list. There are many different collections. The reason why we are doing a dictionary is we want only one object for each path. So what we're going to do is first make sure that our panels exist. This way we don't even have to set it up here. So the first time we will be here, our panels will be null, and we will create a new one. After that, if it contains the path, what we're actually going to do is take that specific one and set it active. We're not only doing that, my keyboard would work a bit better. And we leave. So what does it do? So if our panels equals null, we create a new dictionary. So to make sure that the object exists. If it contains that specific path, we take the game object that is linked to the path and we set it active, and then we leave, because that was basically what we did. We opened a specific panel and then we leave. If we don't find it, we will create it, instantiate it, and then we will add it into the dictionary. So the next time it will actually be there. If we go check now to Unity, we only have one who is there. It's still inactive from the start, so this is again something that we can do. First, check if our panel actually exists. Now we know it does, but it might not stay like that. So panel.setActive true. So this way our panel will always be activated once we open it. Let it compile, press play. We can click once and you see it is active. So our inventory panel is there. We still do not see our panel. So we're going to create a new script, which is going to be our way to find our canvas. So we're going to put the canvas folder on the canvas itself. And if we open up here, scripts canvas folder. So what we want is basically we want it to be static. On start. So game object is part of the mono behavior, and it basically returns the game object this component is attached to. A component is always attached to a game object. So this will always be there here in the start, because this is, you need an instance of the class to run this one. See, it's not static. So once our canvas holder runs, it will save the game object into the canvas holder. What does this do? Well, we can check a few things now. For example, if our panels is null, but we can also check, like, if we don't find our canvas holder, we shouldn't create panels, because that means something went wrong in our setup. And we don't want to do that, so we just leave. This is something we should do always at the start. So when you have methods that are dependent on other things, it's good to check them at the beginning. Like, if it's null, we leave, and that's it. If instead of if it's not null, we do all of this. We basically check. If we don't have what we need, we just leave the method, and we do that at the beginning, so we don't have to go through the functionality to find it. So here we have our panel, and here we go back to transform, and we can set a parent. This will be our, of course, I took too much, canvas holder dot canvas holder, and it also requires a transform. After that, will position stays. So if true, the parent relative position, scales, and rotation is modified such that the object keeps the same world space position, rotation, and scale as before. What does it do? Sets the parent of the transform. So we are not interested in any of this in our UI. So we set it to false. Now we wait for compilation. In the bottom corner, press play, and button clicked, and our inventory panel is created and is locked under our canvas. So this is the start of the UI. It's been 50 minutes, quite a long one. But quick recap, what have we done? So we created a button, we added an image and a label to it, we changed where its anchor and its pivot points are for each individually so that it looks as we want to. After that, we created a small script which is called Open Inventory, and in fact this should probably be renamed to Open Panel. So this is no longer specific for inventory. So we should create rename this Open Panel. Go here and rename it here as well, because So open panel script, open panel, relink a button to it. The reason for this was so that we can add our on-click listener and remove it when we destroy it. Update is never used. And once the button is clicked, we call our UI manager to open a panel. What does our UI manager do? It makes sure that we have a canvas where to add our things to. It keeps a list, well actually a dictionary of all the panels with their path as a key, so there's only one ever loaded. If he finds that specific panel, he sets it active and return. Otherwise, he's trying to load it, instantiate it, and then he sets it to be part of the canvas. Our canvas folder is very simple, holds a public game object, which is our canvas, and on start it basically saves it there. So it is freely available for our UI manager and anything else that would need to create UI. This is the basic UI. I think I will stop around now because we're getting very close to 1 hour for a very short tutorial. If you have any questions, let me know in the comments, and otherwise we will look into creating some more scripts later on how to populate our inventory and how to get data. So I hope this was helpful, and if you need anything else, just